4.4 is proving triangles congruent using side, 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 and side angle side. That's what these stand for up here. So we're going to use those postulates to test for congruence. So side, side, side congruence is when three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So if I sketch a little picture here, and let's say that side was equal to this side, this one went with that one, and that one went with that one. This would be an example of side, side, side. Side angle side is if two sides in an included angle of one triangle are congruent, then two sides of an included angle of the second triangle. Then those triangles are congruent. So what that means is if I have something like this, and let's say that equals that, and that equals that, and this angle in between, so it has to be the angle, that's what it means by included angle. It's the one that's in between the two sides that are marked as congruent. So then you can use the side, side, side postulate. So example 1, we're writing a proof. So we have, this is what's given to us, and it's marked on our diagram already. So QU is congruent to AD, and QD is congruent to AU, and we want to prove that the two triangles are congruent. So I'm going to do a two-column proof here. So my first one, easy one, is the given. QU is congruent to AD, and QD congruent to AU. So there's my given. Okay, so now the other thing that I have in this diagram, which we're going to use this all the time in these triangle proofs, is that this line in the middle, DU, they share that. They share DU on here. So whenever something is equal to itself, I can say on here DU is congruent to DU. That's the reflexive property. Reflexive property of congruence, we'll say. So now I'm going to mark that on here also so I can kind of see. So these are congruent to each other. So now I have all three sides are listed as congruent. So that means I can use my side, side, side that we just talked about to say my final statement. So QUD is congruent to triangle ADU. And that's by the side, side, side postulate. All right, example 2 has the wings of a moth form two triangles. Write a two-column proof to prove that FEG is congruent to HIG if EI is congruent to FH. So first thing I'm going to do as I'm reading this is I'm going to mark this on my diagram. So it says EI, so that's this whole thing. I guess I can't really mark it on there, but and that piece are congruent, so we know that. G is the midpoint of both of those, so that tells me that this piece is equal to that piece, and that is equal to that. So now I have some more markings on my actual triangle here. So again, we are going to start with our given. So this was two-column proof, right? Yep. So my given, I have EI is congruent to FH. So there's my given. So now, using the fact that we have a midpoint on here, midpoint means it cuts it in the middle, so I can make a couple different statements based off of that. I can say that EG is congruent to IG. And I can say that FG is congruent to HG. And that would be by the definition of a midpoint. Or sometimes you'll see midpoint theorem. Either of those are fine. Okay, so now I have two sides on there, so I'm thinking what else can I say based on this diagram to try to get these triangles congruent? I want either all three sides or two angles in the side in between. So whenever I see this X pattern on here, I know that that and that are equal to each other. So I'm going to say FGE is congruent to HGI and that would be by vertical angles. So that's because they're vertical angles. So now I have side, an angle, and a side on both of them, with the angle being included. So I'm going to say my reason is going to be side, angle, side, and I'm taking what I need to prove and putting it down here. So triangle FEG is congruent to triangle HIG. All right, one more. So we have in here, we're going to write a paragraph proof this time. And you are actually missing the diagram on here. So I'm going to add that diagram on. If your paper has it, then you must have got lucky. So this is what we have. All right. So it's given that QR and TS are parallel to each other, so that's why we have these markings, meaning parallel. RQ is congruent to TS, so that's why these markings are on there, saying that they're equal. And then we also have angle Q is congruent to angle S on here. So now, the fact that these are, I could think of these as my parallel lines, and this kind of being a transversal in there, I'm going to say that QRT would be equal to STR on here. So I'm going to say because RQ is parallel to TS, angle QRT is congruent to STR, because they are alternate interior angles. Okay, so now we have that that is congruent to that. I can also say that this piece right here is congruent to itself. So I'm going to say, since RT is in both triangles, RT is congruent to RT by the reflexive property. Reflexive property of congruence. Therefore, so now we have a side, an angle, and a side. So therefore, triangle, so now I'm going to say that these triangles are congruent. So I'm going to say QRT is congruent to STR by, that was side, angle, side. And then lastly, what it wants us to prove is that Q is congruent to S. Sorry, that wasn't given. I marked that as given on there and it wasn't. My bad. That's what we're trying to prove. So now, since we've said that these are congruent, we can use the CPCTC that is listed at the top of your page, which stands for congruent parts of congruent triangles are congruent. So that means once you prove that the two triangles are congruent, we can say that any corresponding part in there, parts are also congruent. So now I can say angle Q is congruent to angle S by CPCTC. All right, so we will definitely practice these more in class together. Take a look at this one and see if you can fill in the reasons for this proof, and you do have the diagram on that one. So lastly, for a joke, Why do fish always sing off key? It's because you can't tune a fish. Okay, hope you have a wonderful day and make sure you're kind to someone today.